Hi, my name is Lindsay Gold, and I'm from the University of Dayton in Dayton, Ohio, and I am a math methods professor for elementary education majors, and I also teach the graduate level educational technology courses, and I'm here with Mike Houston, and I will let him introduce himself.
Hi, everyone. My name is Mike Houston. I teach algebra and calculus at a high school, a very rural high school in the western part of Pennsylvania. I'm excited to be here.
Thanks, Mike. Tonight we're going to talk about algebra, specifically the structure of expressions and equations, variables, and the relationship between the quantities. I'm going to focus on the elementary part, and then I'm going to kick it over to Mike to do the middle and high school part. The technology I will be using is the TI-Nspire App for iPad. And I'll begin by sharing my iPad screen here for you. And it will take just a second to kick over. And while I'm doing that, I can tell you a little bit about what we're doing here. I'm going to be talking about some activities first that are adapted from the NCTM book On the Money. And it's On the Money math activities to build financial literacy in kindergarten through grades 5. And what's really cool about this book is how it incorporates the financial literacy standards and skills into the mathematics curriculum. So I was fortunate enough to write this book with Mike, and then along with Jenny Bay Williams and Johnny Ashurst, we were able to produce this for NCTM. The other shout out I'd like to do is give to the Tootsie Roll Industries for allowing us to use the images of their products during the I've Got a Dollar activity. So thank you to them for that. For those of you that are unfamiliar with the iPad, this is the TI-Nspire app for iPad. You can see on the left-hand part of your screen, there is, under the DEG, there is an icon. If you click on that, it opens up your pages. So I'm going to go to the next page on my screen here. And I want to tell you that underneath this blue bar are some coins. So I have a row of coins here, and I'm going to show you some of those coins, and to reveal them, I'm going to click on the left arrow, and you will start to see some coins that you hopefully recognize as pennies. I would talk to my students about what is a penny, what are the characteristics of a penny, how much is a penny worth, those kinds of things. Pennies are really good for that one-to-one correspondence when working with students. So I would tell them, how many pennies do you see here? And Mike, how many pennies do you see here?
4.
Very good, Mike. And if I tell you, Mike, that there are 6 coins hidden, I want us to try to come up with an equation to represent the total number of coins. So I would ask the students, whether they be using whiteboards or at their desks or things, to come up with an equation to represent this amount. So I will click down here in the bottom, which is part of a notes page, and I am going to click on, whoops, I just went away. I'm going to click on the numbers to go to the numbers and put 4 plus 6 equals, and I'm going to put a blank in there because I want them to see those different parts there. So I've written this equation 4 plus 6 equals blank, and there's multiple ways that students could solve this equation. Some of them are very good at already memorizing their basic addition facts, so they could do it that way. Some of them might need to count on, so they might start at 4 and then count on 6 more. They might even use their fingers, which I like. I always say those are built-in manipulatives, so feel free to use them. But I could tell them 4 plus 6 equals, and hopefully they would tell me what, Mike? What does 4 plus 6 equal?
10 all day.
All right, you're pretty good at math, but I'm going to check you anyways. So let's
Good idea.
reveal 6 more coins. and C. Then the students could count each one of those coins individually if they needed to double check, because I tell them it's always important to check that 4 plus 6 does indeed equal 10. Now, I'm going to show you another example. So I'm going back to that icon to go to the next page. And here we have some coins hidden. Maybe they're pennies, maybe they're not. Let's look. I'm going to reveal some coins to you. Now, this is not a penny. It is silver. It's larger than a penny. It's thicker than a penny, and it doesn't have rigid edges. So, Mike, do you recognize this coin?
I didn't at first, but the non-rigid edges is what did it for me. So I think that's probably the nickel.
I think you are correct. And if you notice, and this is the hard thing about money for students, but this is why I like using authentic materials like this instead of worksheets, because the students can see that there are different pictures or images on the coins. They don't all look the same. So this would be considered the head of the coin, but you'll notice that the coin all the way to the right looks different from the next one, because the next one is actually the newer updated version. So that's why I think it's so important to show the students these authentic materials. So another thing I like about using nickels is, Mike, how much is a nickel worth?
5 cents.
Exactly. So that makes it different from the penny with the one-to-one correspondent, because this time the students can actually count by 5. So I always think that's good. You know, they could do skip counting when they're counting nickels, those kinds of things. But in this case, we want to just focus on there being 3 nickels. And instead of telling you the other part, I'm going to tell you the whole. But before I do that, I want you to take a guess at what you think that part might be. Now, to do that, I always say you want to take a guess. You don't want to just take a random guess, but more of a logical guess. So to do that, a student might look, well, how big is the nickel? How far are they spaced apart? I can see 3. So I'm pretty sure, according to the length of that blue bar, that there's at least 3 more. But I always try to have students use that logic, algebraic reasoning and things when they're doing these kinds of activities. So I'll tell you that there are 10 total in the row. So I want to know this time how many nickels are hidden. So I would ask the students to write an equation to represent the fact there's 3 nickels showing and there's 10 total. So to do that, I'm going to click back down here on the notes pages and the numbers, and I'm going to put 3 plus blank this time equals 10. And so this time they have to figure out the other part. Students might do this different ways again. They might start at 3 and count up until they get to 10. So that's kind of using that algebraic reasoning and that blank in there. Some students might even start to manipulate the numbers a little bit and maybe not use an addition problem. So if I were to show that example, some students might say, Dr. Gold, I did this. I took 10 minus 3 equals blank. So that looks like the first problem we were kind of talking about, where the answer is the blank. But when thinking about algebra and algebraic reasoning, the big part here is that both sides of the equal sign need to be the same as. So frequently when we're teaching students, they see whatever comes after the equals as the answer is. But in this case, I want them to think of it being as the same as. So, Mike, how many coins do you think are hidden this time?
So I think by the numbers you have represented there, I'm going to say 7. But I actually thought by just my first guess that there might be 6. So I think it's
okay. So you predicted 6 until you saw the equation?
I did, until you gave me some more information.
All right, let's check it out. 1, 2, 3, 4, 5, 6. Oops. Here, let me fix that again. It got accidentally moved the bar. That was my fault. Let's try it again. 1, 2, 3, 4, 5, 6. Is it not going to show it this time? So, okay, so the thing about this is that if I accidentally touch the wrong spot, it kind of moves a little bit. So I'm going to try one more time. We'll see if we can move it over here for you to show. Oh, there you go. We'll just move it out of the way. That works. Okay, so you can see there are in fact 7 nickels. And then I would have my students skip count again so they could see how much money it is. But the next thing I wanted to show you was one more of these problems. And this time we have a different coin. And I would challenge the students to pose this problem in terms of coin values. So if I show you 5 of these coins, and the first thing I would talk to them about is, what is it? What kind of coin is that? And we go back to, what does it feel like? What does it look like? And the hard thing with money is, and once again, it goes back to why it's so important to have authentic materials, is a dime is smaller, it's thinner, it does have the rigid edges, those kinds of things, but it's worth more. And that kind of blows students' minds. Like, why would a dime be worth more than a nickel, but so much smaller? So I would talk to the students about that. And we would say, okay, so a dime is worth 10. And if we counted that, Mike, how much money do we have there? What is the value of the coins being shown?
We have 5 coins worth 10 cents a piece, so that would be 50 cents.
Excellent. So I would tell the students, okay, I'm going to give you an idea first, so you could look at it and you could predict, and based on the length, those kinds of things, what they thought it would be. But if I told them this whole row is worth $1, I would ask them to think about that for a little bit. So $1, what is $1, and what does that mean in terms of cents? So we would talk about, well, in $1, that equals 100 cents. So if we have 50 cents here, and we know that the whole row equals 100 cents, I would have them write that equation out for me. So you could see 50 plus blank equals 100. And so then we would talk about how much money is being covered, how much is it worth? Okay, so if you know how much it's worth, so Mike, what's the value of the amount of money being covered?
So it looks like it's like halfway on the screen. So I'm gonna guess there's another 5 coins underneath. So that would be another 50 cents.
Exactly. So we could talk about how if 50 cents are covered and we wanted to look at it in terms of coins, like you said, Mike, it looked like about half, and we'll double check. But there were 5 coins showing, and we know that the whole thing is worth 100 cents, which then in dimes would be 10 dimes. We could see as we reveal how many, 1, 2, 3, 4, 5. And then once again, I would go back with the students and say, count that. So yes, it's 10 coins, but how much is that 10 coins worth? And they could skip count by 10s till they got to 100. And we could talk about how that 100 cents makes up that $1. Okay, so that's one reason why I like using money and doing these, is that you can use them to show the skip counting, but also the algebraic reasoning. The next activity I want to show you is a lot of fun because I give them a real world situation. My grandma gave me $1 for my birthday. I went to the candy store to buy myself some treats. Suckers were a quarter, bubble gum a dime, and Tootsie Rolls a nickel. How many suckers, bubble gum, and Tootsie Rolls should I buy, or could I buy? So we had just talked in the last activity about how $1 is worth 100 cents. So we say, keep that in mind. And then I would also talk to them about just real world. Have you ever been to the store? Have you ever picked out something to buy? How did you know what you could buy or how much you could buy? So any way that we can relate this back to the student's life is good. But in this particular scenario, I would talk to them about what is this problem asking? What are the different parts of this? So Mike, it says suckers were a quarter. How much is a quarter worth?
25 cents.
Excellent. And you know, quarter is one of those things that trips my students up a lot. They confuse, quarter with 25 cents, but then when we go to time, they think of quarter after is 25 after. And so we have to actually talk about what does quarter mean? And a quarter is like 1/4 of something. So when we're talking about $1, a quarter is worth, like you said, 25 cents. Bubblegum a dime, which how much is a dime worth?
10 cents.
And Tootsie Rolls a nickel, and how much are a nickel worth?
5 cents.
Exactly. So those are all parts of the problem that we have to make sure that the students understand, or they wouldn't be successful in completing this task. Other things we would talk about, do I have to spend the whole $1? My grandma gave me $1, but do I have to spend the whole thing? What different scenarios or what different situations could maybe a student not want to spend the whole $1 or maybe want to buy a certain type of this candy? So these are all things that I would talk to my students about. Okay, so let me show you this here. I use this as a way to, once again, model the situation and help the students understand what is being asked. We talked about, you can look on the left, the suckers are worth 25, the gum is 10, the candy or the Tootsie Rolls are 5 cents. But then on the left, you can see the cost of the suckers, and it says 0 cents, cost of gum 0 cents, cost of candy 0 cents, because we have yet to show anything. But what I love even more about this page is the yellow box here that says part of $1 spent and then part of $1 saved. So there's that financial literacy coming back in about the possibility of actually saving some of your money. So I would talk to the students by starting, what if I only had a nickel? What if I only had 5 cents? So Mike, what could I buy if I only had 5 cents?
If you only had 5 cents, suckers are 25 cents. So those are out. Gum, 10 cents, that's out. So you could just buy one Tootsie Roll, one piece of candy.
Excellent. So I would click that left arrow again, and it would reveal the Tootsie Roll that is 5 cents. And look back there at that yellow box again. You've spent 5 cents, but you saved 95 cents. If you're anything like me, that just means I have more money to spend. So I want to keep going. Okay, Mike, what if I had 10 cents? So I'm going to go all the way back to the beginning. What if I had 10 cents, only 10 cents? What could I buy?
So I think now we have some other possibilities. So we could buy 2 pieces of Tootsie Rolls or 2 Tootsie Rolls.
Okay.
And there goes our 10 cents. Or I think we could buy 1 piece of gum.
Let's see. All right, there's our gum now. So we could buy 1 piece of gum for 10 cents, or we could buy 2 Tootsie Rolls for 10 cents. And what I like about this is they start to recognize that pattern. Oh, for every 2 Tootsie Rolls, I could have one piece of gum, or for every one piece of gum, I could have 2 Tootsie Rolls. And so then we start to get into, what is something worth to you? Is it more fun for you to have more pieces of candy, or is it more fun for you to have like a piece that you really like? Okay, so what if I had 15 cents? What are my options now with 15 cents?
15 cents. So we could do what? 3 Tootsie Rolls? That would be 15 cents.
Makes sense to me.
And are we talking about a maximum here? We're trying to spend
Maximum of 15 cents.
Okay, so we're trying to spend all 15 cents.
Yes.
So we could do then 1 piece of gum and 1 Tootsie Roll.
Excellent. So 3 Tootsie Rolls or 1 piece of gum and 1 Tootsie Roll. You could still see, could I have gotten 2 pieces of gum, Mike?
You cannot. That would have been more money than you had.
Exactly. And so once again, it goes back to that, 2 Tootsie Rolls equals 1 piece of gum. So I couldn't do that. So my choices are 3 Tootsie Rolls or a piece of gum and a Tootsie Roll. All right, Mike, what if I had 20 cents? What are my options at 20 cents?
20 cents. So that would be what, 4 Tootsie Rolls, or up to 4 Tootsie Rolls.
Okay. Yep, that equals 20. All right. What else?
Or 2 pieces of gum.
Let's see. Agreed.
And still no suckers.
Still no suckers. Can I have a combination of gum and Tootsie Rolls?
For 20 cents, I think you could. Yeah, you could do 1 piece of gum. That would be 10 cents. And then up to 2 Tootsie Rolls.
Excellent. And you can see very good that it again equals 20 cents. Awesome.
Can I jump in here real quick? So the one
yes, please do.
This visual is, again, just trying to teach students value is always a tough thing to do. And so whenever we have students that look on the right side and they see the cost of gum is 10 cents and the cost of candy is also 10 cents, but then they look to the left and they're like, well, I'm getting 2 Tootsie Rolls, but I can only get 1 piece of gum. I think that's a strong visual for a lot of, I have a 5-year-old and a 3-year-old, and I think that would be important to them, that they're getting 2 versus 1, and it's still costing the same amount. So.
Exactly. So they're equal in price, but not equal in quantity.
Right.
Yeah. Very good. Okay. Now I'm really excited because now I have a quarter. So what could I get with a quarter?
Well, let's jump right to it. We can finally get a sucker. We've been
finally
waiting. Yeah.
I know you've been waiting to see what they look like.
In.
There they are.
I wanted a sucker.
There it is.
And those are my favorite, by the way, in case anyone ever wants to buy me any. Those are my favorite.
Show that one more time. There you go. Tootsie Roll Pop.
Thank
Fantastic.
You. So
okay.
We can get 1 sucker for 25 cents or up to 5 Tootsie Rolls for 25 cents.
True. Excellent.
Or 2 pieces of gum would be 20, and then we'd still have some money left over for 1 Tootsie Roll.
Excellent. So there are more combinations again of how we could spend that 25 cents. So what I really like about this visual is that the students can manipulate these amounts and start to see the patterns and those kinds of things. Because of space, I wasn't able to, put a huge amount of gum and candy. But one thing I was able to do with your suckers, since you so enjoy your suckers. So, Mike, would you say you would spend your whole dollar on these Tootsie Roll Pops?
Honestly, I do love Tootsie Roll Pops, but I think I just love Tootsie Rolls even more. So I'd probably want to do some sort of combination. If I only had $1, I would probably get, I think, 2 Tootsie Roll Pops, 2 suckers. And then I'm not a huge fan of gum, so I would go straight to the Tootsie Rolls and just spend the rest of my 50 cents and just buy as many Tootsie Rolls as I could. I'd get 10 Tootsie Rolls.
I was just going to ask you, so how many could you get?
Yeah, I think that'd be That'd be 10 by my lightning fast calculations.
Very good. Very good. And so that leads us to the next, because of space and not being able to fit all those on there. The next part of the activity is here we could check. So you had said you wanted 2 suckers, but then you wanted to see how many Tootsie Rolls you could get. And so students could keep pushing this button until they got to the point where in the green box, the total is 100 cents and the change would be 0. But what's also cool about this is if you have overzealous students that are like, I'm going to get 20 Tootsie Rolls and 2 suckers. If they tried, notice what happens.
That's so sad.
Yes, this is more than $1. It turns red. Stop. You can't. But it just kind of helps the students to figure out how many different combinations they can have to come up with that dollar. And that's what I think is really cool about this activity, is that the students could put this in a spreadsheet. The students could make an organized list. They could do all kinds of different things to show these different combinations. You could even, kind of talk to your students about algebraically, what does that look like? So they could say, they might not understand necessarily variables, but they could say, well, it's like 25 times however many suckers I could get, plus 10 times however many pieces of gum I could get, or 5 times however many Tootsie Rolls, and that has to balance out or equal 100 cents. So I just think that's really powerful for students, that even before we get into the memorization of what is a variable and what does that do, we talk about what does that mean? What is the purpose? How does that look? So that kind of leads me into your section, Mike. So I am going to come out of my page by hitting the home key, and I'll go ahead and discard my changes. And then I'm going to take you to your section here on what is an equation.
Thanks so much, Lindsay. So before I begin, I just want to add that if you're thinking about different ways that you probably already have your students maybe at the lower levels working with just combining numbers, addition, subtraction, things like that, and how you might be doing it versus if there's a way that you could add a manipulative to that. And if you can make it money, that adds an extra strong layer of learning to the lesson. I don't think it takes a lot of extra time, but it certainly is something that does add dimension to your lesson, and it's important. I think in general, my kids are seeing less and less coins and paper money than I did as a kid. And so whenever they come across it, it's going to be, I think, more difficult for them in general to have a good understanding, a good financial understanding of that if we don't introduce that to them. So thanks so much, Lindsay, for doing that for us.
Absolutely.
So pigging back off of what Lindsay did, she had started to use that equal sign with even just doing some simple addition. And so by the middle school, that equal sign is probably going to be floating around a lot. And I think some places it's definitely used appropriately. And unfortunately, other places it's probably not used appropriately. I even see, again, I teach high school math, and I see even at the calculus level, my students just willy-nilly will just put equal signs wherever they think that it looks like they should put it. And that to me, a lot of times just tells them that they're either not thinking or they're not really understanding what that symbol really means. So I think it's really important that if you're using that symbol and your students are using that symbol, that they're using it appropriately, and that there's a talk about when it should be used and what it really means. So to kind of get us geared up for that, Lindsay, can you actually skip a couple pages here and go to the page 1.3? The page 1.2 just has some text about how to use this particular pre-made document for the Nspire. This is again available on TI's website for free under the building concepts selection of activities. So Lindsay, the first thing I'm going to do with my students, and I'm going to ask you to be my student right now. What are some things that you see on the screen?
So if I were just kind of looking at this screen, I see a number line, and I see that it ranges from 0 to 20. And I see where the point is located at 12. And then I see a number sentence that does not have an equal sign. So
Awesome.
tell me about that.
So, I want my students at the middle school level, especially, and at the high school level as well, to understand what the name of that is inside that purple box. And so it contains numbers and letters. And so that winds up being an expression. And so we could have, for instance, written an expression to represent some of the Tootsie Rolls that I wanted to buy in Lindsay's last problem. Maybe there's a situation where whenever I walk into the candy store to buy my suckers, which are 25 cents a piece, I always wind up buying $2 worth of Tootsie Rolls just because I like to eat them on the way home. So I could write an expression, and I'd want my students to also be able to write an expression, something like 0.25 for 25 cents times some unknown quantity, and we'll use a variable for that. So we can call it X, call it C for candy, whatever you want to use, plus 2, because we're always adding in that $2 I'm going to spend on Tootsie Rolls. And that $2 is not going to change. I always walk in, I always want $2 of Tootsie Rolls. I don't want one week $1 or next week $10. I'm very consistent. I have, getting help for that, but I always want $2 worth of Tootsie Rolls. So 0.25x plus 2 is another expression. The one we're looking at right now is 3x plus 4. And so, there's, before anything happens with my students with this file, we definitely have a conversation. Again, I want them to understand there's a number line up there. I see a dot on that number line. It looks like it goes from 0 to 20. Lindsay, whenever you move that dot, can you see what happens for us whenever we change that dot left or right?
Sure. So it looks like it's changing the X.
So it's changing the value of X. And is it changing by what kind of increments does it look like?
So let's see if I'm here and I go down. It looks like it's increments of 1. So they're integers and not decimals or fractions.
Awesome. Yeah, so it's changing by, I would even want my students to dig deeper and say those are changing by whole numbers. They're not natural numbers because I believe we can go all the way down to 0, and 0 is not included in the subset of natural numbers. But it would be a whole number. It would be an integer as well. So that's great. I want them to understand that language. They're going to see it in their textbooks. They're going to see it on different state testing. So I want to make sure I'm consistent and I'm using the same language whenever I teach. Way back whenever I first started teaching, I didn't use that language because I thought it was too difficult for them, and I was doing them a favor by using more simplistic words. Instead of numerator and denominator, I would say top and bottom, things like that. And I started realizing that it really doesn't help them. It might help them that day in my class, but once they leave or once they try and read something out of the textbook, it's not going to say top and bottom. So I realized I had to make a change in the vocabulary that I was using in my own classroom. All right, so we have a page with a value of X that we can change left or right from 0 to 20. It changes by a step size of 1. And as we change it, it looks like it fills in a value of X. And then if we kind of ticker tape that down and follow some order of operations, we actually get the overall value of the expression when X equals whatever the number equals. And I think this is a great place for many students to jump in because I think a very broad general statement, if you give your students 3x plus 4 and say, what's the value of the expression whenever x equals 0, I think most of them will have the ability and the know-how that they're going to want to substitute 0 in for x and then start multiplying and adding and following the order of operations. So I like this from getting everyone back on board kind of quickly. But this in and of itself is not an equation. In order to have an equation, we need an equal sign, and there's no equal sign here at all. This is just an expression. So Lindsay, in the bottom right, can you click the show equal sign for me, please? Awesome. So Lindsay, what changed and what stayed the same?
So I see what was my expression, those numbers had stayed the same, but now we have the equation that equals 28.
Awesome. So I always want my students to try and think about balance. And so now we have a seesaw effect kind of happening where what I would think of is the heaviness, the weight of the right side looks like it's 28. We're trying to get to 28. And the left side is only a measly 4. And so if you have to move that dot, Lindsay, which direction do you think you're going to move it to try and get us closer to 28 from a value of 4?
So I think I need to go to the right. I think this number needs to continue to get larger.
Awesome. So I would ask my students before they just kind of did the hunt and peck method. I think estimation is a strong skill for students to have. And the more they use estimation, the better estimators they're going to be. So I would want my students, if they were all the way back at x equals 0, and they got a value of 4, to think about, well, where do you think we should land at what x value to give us a value of 28? And, I would want to record those values, probably put them up on the board, and then ask students to maybe, we would randomly pick one of those numbers on the board and jump to it. So let's pick 8, and let's see where 8 gets us. So I swear, I really just picked 8 randomly as randomly as I could. And that turns out that winds up working. So if that wasn't the correct number, I would want to go back to the drawing board, ask my students again, should we pick a number that's higher or lower than 8? But I'm hoping that a lot of students would see that now we have some balance here. The other thing that happened, which I don't know if you caught, if you move the point off of 8, Lindsay, I think that we would be able to see, that below that box on the right, below the 28, if you go back to 8 for a second, we now get a complete equation at the bottom that says 28 equals 28, which I think is pretty slick. It's a really subtle visual, but as soon as you're not on 8, I don't think that is going to work, and it won't show you that it equals 28. So I want my students to think about this. So we found one answer, right? It looks like that if x is 8, then we're good. Lindsay, do you think 8 is the only number that will work for us?
That's a good question. And I think it would be really cool to try some others just to see.
So if I feel like I saw you kind of slide from 0 up to 8. And as you did that, your original value, whenever x was 0, was 4. And I just saw that value grow from 4 and grow and grow and grow, now up to 28. So I'm pretty confident in between 0 and 8, we're not going to get any numbers higher than 28. So what would happen if you maybe go past x equals 8?
Sure.
Let's go.
I'm going to go way up in here.
That's crazy. So just by doing a little bit of exploration, it looks to me like, at least on this number line of 0 to 20, that we're not going to be able to find another number that's going to work and be a solution to this equation. But to me, this is heavy and this is important. And I want my students to understand a few things. That first of all, this is now an equation. So the directions are going to change usually. The directions, whenever we have equations, we typically solve equations. We don't solve expressions. We evaluate expressions because there's nothing to solve. even though a lot of times students will insert their own equal signs into expressions and sort of push that. That's why the directions usually vary whenever it's not something that's an equation. So Lindsay, thanks so much. Let's move off this. Oh wait, there's one more thing that I want you to play with, I think.
Sure.
What happens if you click on the 28? Can you change that 28 to something else? Like whatever you want, make a number up.
I want it to be 45.
45. So if you press enter, so now we're trying to think of, we'll go back to x equals 8 because that was the answer for the last problem. So it must be the answer to this too, right? So let's see if
X
8,
doesn't always equal 8.
so that's not going to work, right? We need to get up
No.
to 45 now, right? And you were, I think, in the 50s, if I remember, like a value of
Yes, I was
55.
at 17 and it said 55, I think.
Okay, so can we try like 16 and see where 16's at?
So I'm getting closer.
So we know we probably still need to move in what direction, Lindsay?
I'm going to go to the left, which is getting then smaller. X is getting smaller. So I'm getting closer again. Uh-oh, now what?
So again, this is great. I don't know if this is where I'd run to immediately after with my students, but this is definitely something I'd want to bring up and talk to before we kind of left for the day or left this lesson. It looks like that we're probably not going to be able to hit 45. We're going to jump right over 45. And so we would need probably something in between the values of what 13 and 14 would be the answer. And again, with estimation, I want my students to be able to say, well, I think the answer is closer to 14 than it's to 13. And depending on what level of math they were in, we could either go through and actually solve this and find the actual correct fractional answer, or we could just leave it the fact that it's something in between 13 and 14.
Yeah, I like that. It is a really good visual for the students to see the difference and how it changes, and how if I move to 13, then that's going to be too far. And I like your thought about estimating. Is it closer to 13 or 14?
Yeah, for sure. Thanks. All right, so can we see what our pages we can play with and explore?
Absolutely.
So if we go to the next big page, we're going to, again, skip over the notes pages, which kind of give you instructions. So I think
How
we're going to
about
go to page
this one?
1.5. So Lindsay, same initial question. What do you notice about this page, or what is the same from this page compared to the last page?
So I still see a number line, and I still see it goes from 0 to 20. And I learned that the purple box inside, that's called an expression. But I don't, what is this steps thing with the up and down arrow?
So I don't know. Let's just explore and play. So go ahead and move that point that's at x equals 2 and start moving it and see what happens. Whoa. So it looks like we're getting fractional parts, right? So so now first I want my students to be able to talk about what kind of numbers these represent. And so numbers that either terminate or repeat, like these fractions will, these are all going to be rational numbers. And so now, like the issue we have with the last problem, where we were kind of in between two nice whole number values, if we had the same expression, maybe we could have played with it with this page to see if maybe we get it to work. But this is going to allow us not just a step size of 1 where we just jump from 8 to 9 to 10, but now we get those step size to be smaller. Now our step size is a third. And so can you, just because the numbers will be a little bit easier for me, can you back that dot
Absolutely.
down a little bit? So with 2 2/3 for the value of x, The one thing that I just want to bring up that whenever I saw this immediately came to my mind is my students typically without a calculator have a lot of trouble multiplying, say, 6 times 2 2/3 together. In general, I find a lot of my students have trouble with mixed numbers. And again, this is even at the high school level. A lot of my pre-algebra students still struggle with mixed numbers. And so one thing that I've kind of, at least at the high school level, gotten my students to kind of think about with mixed numbers is I ask them to say the number back to me. And so I would ask them to say that number is 2 2/3. And I ask them to say it slower. And whenever we hit the and, I would ask them to pause for a second. And so they would say 2 and I would say pause. And I'm like, all right, what math symbol is representative of the word and? And they're like, I think that's addition. I'm like, righto. So 2 2/3 is the same as 2 plus 2/3. And so if you can kind of visualize, do a quick what if on the screen, imagine that instead of just writing it as a mixed number, that it was written as 2 plus 2/3. If it's written as 6 times the quantity, 2 plus 2/3, that as an algebra teacher screams distributed property to me. And so I want my students to be able to think about doing that kind of math without a calculator, especially since we're talking about numbers like 6 and numbers like 2/3. So I want them to be able to do 6 times 2, right, and get 12, and then think about what 6 times 2/3 would be. And so we're dividing the 6 up in 2/3, and we want to have 2 of those, right? So that would be what, 4? So I have a 12 and 4 more, and you can see it gives me the 16. So if that's something you've never thought of, I encourage you to ask your students to think about it that way. If they're at that level where they can kind of separate that mixed number into 2 different parts or 2 different pieces, and you can think about the multiplication as 2 different steps as opposed to just kind of one. And then, so let's play with this for a minute. It looks like we can probably change the step size, Lindsay.
Okay.
So why don't we just play with that, see what kind of steps we can play with. So we have maybe some easier steps for your students, like 1/4 compared to 1/3. I don't know. 1/5. Ooh. How high does it go? Let's push it. Okay.
Oh,
so
I think I reached my max.
Okay, so we can get a step size as small as a 12th. And so even though this particular activity probably is more likely found in the middle grades room, I can almost guarantee that if I were to give this to my high school students to think about with step increments of a 12th or even an 11th or even a 10th, that right off the bat is going to really raise the level of degree of difficulty for them. So if we click the show equation in the bottom right, Lindsay, let's see if we can make some magic happen here. So we're trying to get a 9, and that's pretty cool because we're already at 9.5. So I would ask my students again that same question. So we're at an x value of 9/12. We're trying to get our 9.5 down to a 9. So which way do we have to move the point, Lindsay?
So I feel like I want to make it smaller.
Awesome. So smaller to you means go to the left.
The left. Well, now I kind of went too far. Oh, there we go. So I explored. I went too far and then I came back.
Nice. Nice. That's a great skill. So you're at 8/12. And then I'm definitely going to push. If we're dealing with 12ths, I'm going to ask if anyone else in the room has used other steps and found a similar answer to try and get my students to think about that idea of equality of fractions as well. Awesome. Thanks so much, Lindsay. I think this guy is wrapped up. There's a lot of other stuff that can be done and found with this particular activity. Again, it's all pre-made. It's all built in. There's preload student document if you want to use it, preload teacher notes. I, a lot of times for the preloaded activities that are written on TI's website, sometimes I find myself using them as they're probably originally intended with the students, with a student handout, and we walk through every step. Other times, sometimes my students just need the visual. And some of these files are really great just to bring up whenever my students are having trouble, and I can bring that visual back in. So thanks so much, Lindsay. Can we switch over to the other file that I want to use tonight?
Absolutely. So I'm going to go back to the home and visualizing equations using mobiles. Do you pronounce it mobiles? Mobiles? How do you pronounce it?
I think I've always said mobiles, but
Mobiles.
every time I say it, I always like feel like I have to catch myself and think whether I'm saying it right or not.
Right.
All right, so let's check out the page sorter view, because again, there's probably a lot of stuff that we could look at. So again, you'll find in this file there's a lot of text. If you wanted to read through about the specifics of how to do this with your students. One of the beauties of this is if you wanted to, again, you don't even necessarily need any paper copies. So in a virtual world, if you didn't want to even scan anything or upload anything, it could just be the file that students can either have on their app, like Lindsay's using tonight, or on their student software. And again, this is all, if they're interested, on TI's website, it's all available. Trial versions are available for free with the exception of the app. That's available through the iTunes store. But as far as the student software, that's something that they can download for free. And they can view this file on their student software and really kind of go at their own pace, read through the directions, if you happen to be working remotely right now. All right, so let's check out page 1.3. Awesome. So I see some pretty triangles and squares, and it looks like our mobile has some stuff going on. Lindsay, would you say it looks balanced right now?
I would say it does. That line is pretty straight to me.
Okay. And so in order for it to be balanced, then what do we know has to be true?
That the sides have to be equal.
Awesome. So right now it looks like you have an underline with the blue square of 0. So
yes.
That makes me think that we could probably change that to something. So change it to whatever you feel like, whatever number you're feeling like right now.
Uh-oh, I tipped it.
So before, I didn't catch Lindsay in time. So before Lindsay would have pressed the enter on that 2, I would have asked her to think about, well, which way is the scale? Is the mobile still going to remain completely horizontal, or is it going to tip one side or the other, and why? So those are all really important probing questions that you want your students to think about. So obviously we have now the blue squares have a weight of 2 compared to our triangles still have no weight at all. What do you think is that 6 at the top, Lindsay?
So yeah, I was thinking about that. If my squares weigh 2 and I have 3 of them, I bet that's where that 6 is coming from.
So that might be like the total weight on the entire system.
Exactly.
Right? Awesome. So so what would you probably want your students to do now, Lindsay? Now they put a 2 in for the blue squares.
So I would like them to explore a little bit to see what the triangle might equal, or how they would have to manipulate the numbers to get it back to where it's balanced.
Yeah. So why don't you do that? Why don't you take a few seconds and just sort of play with the yellow triangles and see what you can see. So
if it's 1, there's 2, it looks like it's getting more balanced. 3, see what happens if I go 4. I think I was closer with 3.
And I didn't notice this earlier, but I just noticed it now. It looks like when we're balanced, the number at the top changes color. Can you change the yellow triangle so we can double check that to something else?
I will. 2, it's black. It looks black on my screen.
Yeah, mine too. And then whenever you change it to a 3 for the yellow triangle, do we get a
maroon? Is that the color?
Reddish.
Brown?
Yep. Awesome. So we're balanced. Yeehaw. That's all well and good. So I don't know. I'm trying to think about where I'd want my students to go from here, because I think it's great that they were able to balance it. But I see some like objects on the right-hand corner, the right side of the screen. I see a trash can in the lower left, and I'm one of those guys that like will go buy something and never read the instructions. I just start trying to see what I can figure out on my own. So pretend you're me. By the way, Lindsay's awesome in driving everything tonight. So the whole time we've been seeing Lindsay's screen, and we didn't switch back and forth to make things a little bit cleaner for you. So anyway, so Lindsay, go ahead and just play and see if you can break it.
Yeah, so I want to see if I can pull some of these off and trash them, get them to that trash can. So it looks like I can do that. And it looks like if I click on the shape on the right and drag it over, I could actually add it to the mobile as well. So that's pretty cool. And now I've made it unbalanced.
I love it. I love it. I love that students can just play, and there's no like, what if I screw it up? It's no big deal. There's a big reset button in the upper right-hand corner if you really get scared. But you know, this is a really low, to me, it's a low anxiety kind of math project to work on, where I think students have the potential, if you're asking the right questions, to gain a lot out of this. So whenever we start going back and we start talking about our equations, if we back that up one step, we go back to thinking about our expressions. To me, each side of that mobile has a different representative expression to it right now. And I'd want my students, especially at the high school level, to be able to represent each side with an expression. And I would hope that at some point, because early on, whenever we start using the equal sign, like Lindsay said, usually the one side of the equal sign tends to be just a number and we're done. But once students get a little bit older and they're doing more advanced math in middle grades or high school, they'll realize that the likelihood of that happening it's smaller and smaller. So it's more likely that they'll have expressions on maybe both sides of their equation that are going to need to be solved. So Lindsay, thanks so much. Let's just go to one more page.
I think we're getting close to time. Did you want to check out this page real quick?
I think that last one that's completely blank, and it's going to take me 30 seconds, and then I promise we'll wrap things up. Sorry.
You're fine. Can you see it?
Not yet.
Okay. Let's see. Well, we might have to.
It's okay. So I'll just kind of describe one of my favorite pages that are available with that activity is just a blank bar with nothing hanging at all. And it adds an extra pink circle. And so you have now three different variables that you can add in, change numbers, and it's a completely blank slate that you can bring to both sides of that mobile. And I think that, again, just as far as extending the learning, trying to get your students to think about, again, those expressions and those equations, I think is really, really powerful. So Lindsay, thanks so much for asking me to help and for showing all the cool stuff and definitely getting us thinking more about financial literacy.
Oh, my pleasure. And I appreciate you, Mike, and going over all the algebra and seeing how it spans the grade levels. It's really nice to know where we've been and where we're going. So that's why I think it's so important to do this vertical articulation across. So thank you.
Thanks everyone for joining us.
Have a good evening.
Bye guys.